Okay, in question 2, we're given a description of something that happens with the parent function f of x equals x squared, and we're asked to generate a new function g of x that matches that. I can't help it. I've got to take a moment and look at GeoGebra. Notice a couple things here. We're going to be compressing it vertically by a factor of 1/2, and then translating it 2 units to the right and then 4 units down. So let's go ahead and look at our parent function. There it is. It's great. F of x equals x squared. And I'm going to subject this function to a couple changes, right? First thing I'm going to do is I'm going to take 1/4 of x squared. So I'm just going to say 1/4 times whatever x squared is producing as outputs, and I press enter. As soon as I do that, you can see, right here, for example, when x was 1, it was going to 1. Now it's just going down right here to 1/4. When x was 2, it was originally going up to 4. Now it's going down to 1/4 of 4, which is at 1. So this is a great demonstration of what happens when and how we vertically compress a function, right? This whole thing has been squished towards the x-axis. Next thing that it says is that we're going to take this function and translate it 2 units to the right and 4 units down. I'm going to go ahead and do the 4 units down first because that's easiest. So I'm going to take this function and I'm just, now it was g of x where I left off. So I'm going to take g of x and I'm just going to subtract 4 from that. And I get, boom, this function. So this is it, me translating it 4 units down. And then finally, I need to take this thing and I'm going to move it 2 units to the right. Well, in order to shift left or right, instead of adding to the result from the function, like we're doing if we're shifting up or down, we're adding to what the output of the function is. If I want to shift this either to the left or the right, I have to change the arguments going into the function. So what I'm going to do is the last function I have here is h of x. I'm going to take h of x, and instead of putting in x's, I'm going to look at h of x, x minus 2. So I know from experience and I know from rules that I've looked at, if I subtract 2 from these input values that are going into h of x, it'll take that function and slide it all the way over. So this final curve is the answer, and I can drag the function out on the screen right here so you can look at it. It's 1/4 of x minus 2 quantity squared minus 4. And that is this curve right here, this one that's darker now. Okay, so that's a nice look at it, but that doesn't help you because you don't necessarily have GeoGebra sitting in front of you when you're taking the test. So what we talked about is the vertex form of an equation. So we've got f of x equals a, some number a, and this produces my either vertical compression or vertical stretching. If a is between the absolute value of a is between 0 and 1, it's going to be taking this function and compressing it. Whenever the absolute value of a is greater than 1, it'll be stretching it out. And when a is equal to 1, it'll match the parent function exactly. And then we've got this x minus h, quantity squared, and then plus k. So these values h and k are the values that indicate the vertex of this new function. So if I'm moving a function 4 units down, this right here would be -4. And if I'm moving a function 2 units to the right, this h right here would be, let's see, 2 units to the right would be a +2. And then, of course, this right here is going to be 1/4. So I can write it down as just 1/4 times x minus a +2 quantity squared, and then, oops, not +4 because we're moving 4 units down, minus 4 units down. Question 3 asks us to find the minimum or maximum value of a given function here. Maxes and mins of quadratic functions, parabolas, right, always occur. I know this is a quadratic because it's a second degree polynomial. They always occur on the axis of symmetry. So, and the other thing that I know is because the coefficient right here is -2, I know that this particular one's opening downward. Because it's opening downward, this function will have a maximal value. It will reach this value right here, and everything else will be below that. So this function has a maximum. And I need to find out what that max is. Well, that max value is going to occur right here, the opposite of b over 2a. In this case, right, b is positive 16, so we're looking at the opposite of 16 over 2 times a negative 2. So we've got negative 16 over negative 4, which means my maximum value occurs when x equals 4. Now, that's not the maximum, that's just where it occurs, right? It occurs when x equals 4. The question now is, well, what is that value, right? When x is 4, what is that maximum value this function spits out? So in order to find that, I need to plug this into the function. So I need to evaluate f of 4, and that equals the opposite of 2 times 4 gets squared plus 16 times 4, and then minus 27. When I plug those values in, I can simplify this. This is a negative 32. 4 times 16 is a positive 64 and a minus 27. So that value is equal to 5. So I have a maximum value, and the maximum value is 5. It occurs at the point when x is equal to 4. Let's finish this question since we're on this page, and then we'll start a new video. Number 4 says, find the roots of the equation x squared plus 2x minus 35 by factoring. This problem is super because a is equal to 1, so it'll be really straightforward to do, right? Once we find the values here, and I'm going to assume, because my teacher is not cruel, that this is factorable. That may not be the case, but I'm going to use the AC method of factoring that we've discussed in class. A times C is the coefficients of the squared term times the constant. So this is going to be negative 35. And if I'm looking at negative 35, I can break that down as a 5 times a 7 and the 1. And one of those two factors is going to have to be negative. So I've got a negative 1, a 5, and a 7. And I've also got here the value of b, which is 2. Okay, the key to this is finding two values, and I don't care what you would call them, two values that have a product of negative 35, and they have a sum of positive 2. So when I'm flying through here looking at 4 such values, it doesn't take me long to realize with 5 and 7, I clearly see they have a difference of 2. So the numbers are negative 5 and positive 7. Negative 5 times 7 equals negative 35, and negative 5 plus 7 equals 2. Because a is 1, I don't need to do the splitting and the factoring by grouping. I'm finished. The factored form of this is x minus 5 times x plus 7, and that product equals 0. The only way that I can get a product of 0 via multiplication is if one of those factors actually equals 0. So we're going to come in here and say, well, either it is the case that x minus 5 is 0, in which case x would be positive 5, or it's the case that x plus 7 equals 0, in which case x would equal negative 7. So my two roots are negative 7 and positive 5.